Good afternoon, all. So we are going to start the session. This is week 9 Microelectronics Device to Circuit session. I'm Arpita Biswas from IIT Jodhpur. I'm pursuing PhD in Electrical Engineering Department. So let's start the session. Am I audible? Hello.
Yes, ma'am.
Okay. So this is more details about me. So here we are going to solve some of the numericals question and some of the MCQ type of question. So this is question number 1. So please try to solve this question. So what is the right answer?
Option 3.
Yes, option C. So here one. So can you explain how you have solved?
Yes, ma'am. Um, Tau is formula is Rs plus Rp into Cs, ma'am.
Yes. And tau p?
And tau P is equal to Rs into Rp by Rs plus Rp into Cp.
Yes. Rp parallel with Rs into right. So
Cp.
option C is the good. So this is the question number 2. Find the bandwidth of the network shown in the figure below and consider the CS is equal to picofarad, CP is equal to 4 picofarad, RS is 5 kilo ohm and RP is 2 kilo ohm. So try to solve this. And for tau S and tau P, use the previous answer. Okay, find out the FL and FH where tau S is equal to 14 nanosecond, I think second, right? Yes, nanosecond. And if tau P is 5.17 nanosecond. Use this parameter to find out the bandwidth.
Option C, ma'am. 16.5.
Yes. Can you little bit explain how you have calculated?
Yes, ma'am. Tau is value already determined from last question and tau P also, ma'am. FL, low cutoff frequency is equal to 1 by 2 pi tau S. And I cutoff frequency 1 by 2 pi tau P. So we have to
Yes.
find FL and FH, ma'am. And bandwidth is equal to FH minus FL.
Minus
So
FL.
value is 16.63 million megahertz.
Yes. The right answer is 16.5. I'm not solving because I think only in this session. So this is question 3. Due to the Miller effect, common source have dash input capacitance and dash out cut C FH. So what is the right answer?
Option C, ma'am. Large and low.
Yes, large and low. So this is question 4. A source follower amplifier has dash input impedance and dash output impedance.
High input and low output.
Yes, option right.
B.
Yes. This is the question number 5. The gain and bandwidth of emitter circuit is dash and dash.
Option B, ma'am.
Yes, option B. Low, close to 1 and wide band gap.
Yes,
This is
ma'am.
the question number 6. Find out the output capacitance for the common source amplifier shown below. Consider CGS is 33 F farad and CGD is 10 F farad and CDB is 16 F farad. So this is the circuit. Try to find out the right answer.
Ma'am, will you please explain this question?
So at first you have to find out the AV, the gain. Tell me the equation, how to find out the AV. AV equal to minus GRL, right?
GMRD.
Yes, GM into RL here. Okay. So calculate it and tell me what is the value of this AV. It's 8, right? So next you have to
Yes, ma'am.
find out the C output, the output capacitance. So you the C output. Do you know the equations how to find out the C output Miller? Tell me. CGD into 1 minus 1 by AB. Okay. So calculate it and tell me what is the value of this C output Miller. Every value is given. Tell me what is the value of this C output Miller. CGD, GD given into 1 minus 1 by AB. Calculated minus 8. So minus minus it is plus. So CGD into 1
Third
plus,
option, ma'am.
yes, option. Okay. So 11.25, right?
Yes, ma'am.
So 11.25 C. It is the C output Miller. It is not the actual C output. Okay. So now we have to find out the C output. C output equal to C output Miller plus CDB. Now tell me what is the value of this C output. C output Miller equal to 11.525 plus CDB. What is the value of this CDB?
27.27.
Yes, sir, 27.25. CDB is 10 femtofarad. Uh, sorry, CDB G 16. So what is the value with 27.25? So what is the right answer? Is the right answer.
Fourth
That,
option.
yes, option D. To at first find out the AV, then find out the C output. If Miller is present, then you have C output. So C output equal to C output Miller plus CDP. So this is
Ma'am,
the
how
question.
do we know whether Miller is present, ma'am?
See here it is mentioned na the common source amp. That's why I have taken the C Miller calculated. You have to check whether the connection is in which amplifier you are using. Mainly the common source amplifier in the, I think the lecture mentioned. Go through the lecture video. The common source amplifier, you have to at first find out the C output Miller, then find out the C output.
Okay, ma'am. Thank you.
Okay. And also see this will also present where you are going to calculate it, because C output Miller plus one more question I am going to solve here where you have to find out, I think, C in. Let's check. So this is the question. When the negative feedback is applied to an amplifier, its voltage gain reduces by a factor of dash. See, it is negative feedback. Tell me the right answer.
Option A.
Is it option A?
Option B, ma'am.
Yes, option B. Negative feedback means always here or think here it will get some positive term, because 1 minus something it is negative feedback, then minus minus plus, so 1 plus A into beta. So this is the question number 8. Find out the pole frequency FH for the source amplifier shown below. Consider the CGS, CGD and CDB. Some these values are given. So you have to find out the FH, the pole frequency. At the in the same way, you have to find out where you in that question you have find out the C output Miller this question, because it is also the common source amplifier, this question at first you have to find out the AV, then C input Miller, and then C input. And what is the formula? C input Miller equal to CGD into 1 minus AV. Okay. Then C input equal to C input Miller plus CGS, because it is input side. Okay. C input. And find out the FH. What is the formula? How to find out? FH equal to 1 by 2 pi R in into C in. Okay. So let's calculate it.
Now for RN, we have to take 10 kilo ohms now, ma'am.
Uh, RL value is not given here.
RI is equal to 10 kilo ohms.
Yes, it is 10. R
Okay,
input
ma'am.
equal. Here it is given R in. I'm just writing here the equation. You have to find out AV. At first, you have to find out the AV. AV equal to minus GMRL. Then you have to find out the C input Miller. And please practice this type of question. Here I am practicing only the 1 or 2 question, but you have to practice more for your exam. CGD 1 minus AV. Just calculate and tell me what is the value. And then finally the value of C input. C in Miller plus CGS. And then tell me what is the value of the C input. And you have to find out the. So what is the value of this FH? The formula is 1 by 2 pi RC. R is R in into C in. Now tell me what is the value of this FH.
Option B, ma'am, 129.39 million
Yes,
amps.
option B is the right answer. Now tell me what is the value of this AV?
AV is equal to minus 8, ma'am.
8. Okay, and what is the value of this C in Miller?
Similar 90 F farad.
Farad. Yes, 90 F farad into farad. And what is the value of the C in
123 F.
123 F farad? And finally, this is
129 point.
29.39 megahertz.
Yes, ma'am.
Then question number 9. Amplifier has an open loop gain of 100. The gain is reduced to 80 when the negative feedback is applied. If the same feedback network is used, amplifier having open loop gain of 50, the closed loop gain would be. So try to find out the right answer. Carefully see what values are given here. These 3 values are given. What is the formula of this loop? Just apply this one. F equal to ay. A, it is suffix. You can take A is suffix. A, it is negative feedback. So beta. So at first, what is which value is given? A is here given. It is 100. A is 100. First condition A is 100, and the gain is reduced by A. So AF is given 80. The reduced. Sorry. If is given. Okay. So here you can find out the beta value, and then the new thing is the same feedback network. It is used for amplifier open loop gain, and if it is changed, like if A is 150, in that condition, the closed loop gain you have to find out. Tell me how to find out it. So from at first you take equal to 100 and A equal to 80, and tell me what is the value of this beta. If we first condition, then that A equal to 100, the open loop gain is 100 and it is reduced 80. So A equal to 80. Then tell me what is the value of this beta. Just put the value of A equal to 80, A equal to 100, and what is the value of the beta.
Ma'am, I get value 2.5 milli.
2.5 into 10 to the power
Milli.
minus 6. Yes. 2.5. So here you have find out the value of the beta. Now you have to find what we have to calculate to gain. If the
Yeah.
gain is 150. So use the same equation where, so you have calculated the beta value and use the same equation. So if mu you have to find out. Okay. If this A value we have to find out if A is 150 now. So A is 150 and beta value already we have calculated. Now tell me what is the value of this A. This is 150.
Option B, ma'am.
Yes, option B is the right answer. So is it clear for all of you how to find out? Just take the first condition that A is 100 and reduced it is 80. So here you have to find out the beta value, and then next condition is if the open loop gain is 150 and closed loop gain would be, so AF new gain you have to find out, where A is 150 and beta from the previous equation we have calculated the beta. So AF is equal to 09.09. This is the question number 10. Refers to the use of the transistor connected in the dash configuration to provide the current buffering for the output of a dash. So find out the right answer.
First option, ma'am.
Yes, option A is the right answer. Common gate and common source. The question number 11. Pole of a transfer function correspond to. So what is the right answer here? A pole of a transfer function.
Option B, ma'am.
Yes, option B. Frequency at which the transfer function becomes infinite. Next question 12. The of a transfer function correspond to. First option, gain increasing to infinite, transfer function becoming zero, maximum phase shift or minimum phase shift.
Option B, ma'am.
Yes, transfer function becoming 0. Next, a system is stable if its poles are located.
Option B, ma'am.
Yes, left half of the S-plane. Good. Question number 14. If lie on the J omega axis of the S-plane, the system is stable, unstable, or marginally stable, or oscillatory, or none of the
Option
above.
C, ma'am.
Marginally stable. This is the question number 15. The slope of a board plot beyond a single pole frequency is.
Option B, minus 20 decibel per decade.
Minus 20 per decade. Question number 16. Corner frequency of RC circuit. Given the R equal to 10 kilo ohm and C equal to 1 micro farad. So you have to find out the corner frequency. Take your time and try to solve.
15.9 hertz.
Yes, 15.9. Jane, how to solve it?
No idea, ma'am. Can you explain?
Tell me how to solve this question.
Ma'am, tau is equal to RC, ma'am, time constant.
Yes.
So we get 10 millisecond as the time constant.
So you have to find out the FC equal
Fc is
to
equal to 1 by 2 pi tau.
2 pi into RC.
Tau.
RC
Tau or
here
RC.
equal to RC. Yes. So the value is given here 1 pi R equal to 10 kilo ohm. So this value is about 15 point hertz. So this is question 17 bandwidth. So for an amplifier FL and FH given. So tell me how to find out the bandwidth.
FH
FH
minus
minus
FL.
FL, ma'am.
Yes. So what is the value? Bandwidth equal to
9.9 K.
so 9900. So next, if C is double in RC filter, what happened to the cutoff frequency?
Will you display the 17th question once again, ma'am?
Sorry,
Will you please display the 17th question once again?
I'm not getting you. Hello?
Hello, ma'am.
Yes.
Will you display 17th question once again?
Which question?
17, 1 7.
Okay. This one.
Yes, ma'am. Thank you, ma'am.
Th- uh,
18th
this,
one, ma'am.
this one directly just you have to minus
Yes, ma'am.
the
Yes, ma'am.
10 kilohertz minus the 100. Okay.
Yes, ma'am. Thank you, ma'am.
Okay. So this is question number 18. C is double filter. What happened to the cutoff frequency?
Becomes half.
Can you little bit explain how it is half?
Generally, cutoff frequency is equal to 1 by 2 pi RC, ma'am.
Hmm.
So if we doubled C into converting C into 2C,
Hmm.
the remaining value becomes 1 by 2 of the already existing value, ma'am.
Yes. So cutoff frequency become half. See, what is the formula of cutoff frequency? By 2 pi RC, right? So C becomes 2C. So what happened to the cutoff frequency? This is the cutoff frequency mu. So this is 2C. So this portion is the FC by 2. The cutoff frequency half. This is the question number 19. The main reason to study the high frequency response of common source or common amplifier is first option to understand the DC biasing stability. Option B to determine the bandwidth and gain variation with frequency. Option C to improve the thermal stability, and option D to reduce the noise at low frequencies.
Option B, ma'am.
Yes, option D is the right answer. To determine the bandwidth and gain variation frequency. This is the question number 20. The high frequency cutoff 3 dB frequency of an common source amplifier is given by. So what is the right answer?
Option B, ma'am.
D is the right answer. Good. Question number 21. Uh, this is given the R value is given, C, G given. So you have to find out. Tell me how. At first, you have to find out the value of this. Tell me what is the formula, the FH. How to find out the FH? We have already, I think, calculate in one problem. 1 by. Tell me what is the formula of FH?
1
1
by
by
1
2
by
pi
2.
R 6 CN, ma'am.
uh,
CN.
into C in, right? Now tell me how to find out. This all values are given. How to find out the C in? What is the formula to find out the C in common source amplifier?
CGS plus
Yes, CGF plus
CGD into 1 minus AM.
1 plus GMRL, right?
Yes, ma'am.
Yes, 1 plus the symbol where is plus is added now, just cross check it. If any just cross check it. 1 plus GMRL into. Now tell me what is the value of this C in. This is CGD. Now tell me what is the value of C in equal to CGS plus 1 plus GMRL into CGT. CGS value is given, CGT value is given, GM value is given, RL is also
52
given.
pico.
Yes,
C.
picofarad. 52 picofarad. Now tell me what is the value of this FH? Here the put the value. Tell me what is the value?
153 kilohertz.
1.
53 kilohertz.
Yes. 153. Jen, are you getting the same answer? Yes.
Yes, ma'am.
Okay. So this is the 22 to find out the input capacitance and cutoff frequency. I'm giving you the equation. Tell me how to find out here the pi C mu value is given. The C input, you have to find out the C input value, which is C pi plus 1 GMRL into C. And then you have to just put the value and tell me what is the value of the C in. And you have to find out the cutoff frequency, the FH. What is the value of this FH? 1 by 2 pi into C in. Tell me what is the value?
I'm seeing 532 picofarad.
Yes, 530 farad.
And cutoff frequency 29.9 megahertz.
So it is 30 kilo ohm near about, right? 30 kilohertz, sorry. Kilohertz. Jen, are you calculated the answer? Are you getting the same answer?
Calculating, ma'am.
Okay, calculated. Just cross check it. Are you getting the same value or not?
Okay, ma'am. Yes, ma'am.
Okay. So this is the question number 23. The Miller capacitance in an amplifier is expressed as. So try to find out the right answer.
Option B, ma'am.
No. Option A is the right answer. Just cross check this plus or positive or negative sign. Just cross check it, okay? The small signal output resistance of a source follower ultimately. So, but the output resistance of a source follower. Yes. Tell me the right answer.
Option C, ma'am.
Yes, option C is the right answer. R output equal to 1 by GM parallel with the RL. This is the question number 25. High frequency cutoff of emitter follower given. R pi is given and C pi is given. Just find out the FA, the cutoff frequency. At first, tell me the equation. How to find out the cutoff frequency FH? So, what is the formula? 1 by 2 pi into R pi into C pi. Now, just calculate it and tell me what is the value. Tell me what is the value of this cutoff frequency?
3.18 gigahertz.
Yes, 3.18 megahertz, right? Jane, are you getting the same
Yes, ma'am.
answer?
Still calculating, ma'am.
Okay, at first calculate and then tell me.
Okay.
So your exam is over or in the next?
What exam, ma'am?
This microelectronics device to circuit?
October last week, ma'am. Exam.
October
Okay,
26th, I think, ma'am.
okay, okay.
Ma'am, what is the answer? 3 megahertz?
Yes, 3.18
Uh,
megahertz.
yes, ma'am, getting the answer.
So this is the question number 26. Miller capacitance effect. If C mu is farad and AV is given minus 10. So compute the effective Miller capacitance CM. Just tell me the equation. How to find out this CM.
CM is equal to C mu into 1 plus AB.
1 plus AV. Yes. And find out the value of this CM. Mod of AV.
22 picofarad.
Yes, 22 picofarad. Next is the question number 27. For MOSFET, GM is given. So find output. So what is the equation? How to find out the R output?
1 by GM parallel to RL.
RL. Yes, 1 by GM parallel with the RL. Now tell me.
243.9 ohms.
244, right?
Yes, ma'am.
Yes, almost 244 ohm. Jane, are you getting the same answer?
Yes, ma'am.
This is the question number 28. The main advantage of a differential amplifier over a single stage amplifier is. So find out the right option here. The advantage of a differential amplifier.
C, ma'am.
Yes, option C is the right answer. High rejection of a common mode signal. The question number 29. The common mode gain ACM of a perfectly balanced differential amplifier should ideally be finite zero equal to differential gain or negative.
0.
Question number 30. The upper cutoff frequency FH for the differential amplifier is approximately given by. So which one is the FH? Already, I think multiple question we have solved.
A option, ma'am. Option A.
FH equal to 1 by 2 pi RC. This is question number 31. Cutoff frequency calculation for differential amplifier. So source resistance is given and source capacitance is given. Find out the FH, the cutoff frequency, and not going to solve. You are going to solve this question. At first, tell me the equation. How you have to find out the FH?
1 by 2 pi RSCS, ma'am.
Yes, 1 by 2 pi RSCS. Just put the value and tell me the value of this FH.
159 kilohertz.
159 kilohertz. Yes. 159.1 kilohertz. Question number 32. Negative feedback in an amplifier is achieved when feedback signal is in phase input signal or out of phase by 180 with the input signal, greater than the input signal or equal to the input signal.
Option B, ma'am.
Out of phase. Out of phase by 180 with the input signal. Then the question number 33. The overall gain with the negative feedback is given by. Tell me what is the right answer. Overall gain.
Option B.
Yes, option B. And the product of A beta is called which gain? Gain feedback factor or desensitivity factor or gain bandwidth product?
Option B, ma'am.
Yes. No, it is not feedback factor. It is called the loop gain.
Okay, ma'am.
Option A is the loop gain. Next, the 35. An amplifier has an open loop gain to 500 and feedback factor beta 0.02. Find out the closed loop gain. Tell me what is the formula to find out the closed loop gain. Tell me the formula.
AF is equal to A by 1 plus A beta.
Yes. Now tell me the value.
45.445.
Yes, 45, 4, 5 point. Jane, are you getting the answer?
Yes, ma'am.
Okay. So here I'm ending the session. Next we will meet next Tuesday, 7 to 9 p.m. You can leave. Okay.
Thank you.
Okay, ma'am. Thank you, ma'am.